Hello all, welcome to the session on FHIR Sync Agent. My name is FHIR and I'm a Fast Track Solution Architect. This Tech Talk is prepared by Fast Track Cloud for Healthcare VT and is recorded on 27th October 2021. The FHIR Sync Agent Tech Talk is organized into three parts. In the first part, we cover architecture, overview of FHIR Sync Agent, components and dependencies, along with the data flow. In the second part, we cover prerequisites, installation, and configuration involved in setting up the FHIR Sync agent, along with the Dataverse mapping. Towards the end of this, we also included Microsoft Docs for additional references. In part 3, we go through few integration scenarios with sample use cases and end the session with best practices in terms of scaling and performance. In this first part, we'll start with FHIR Sync Agent overview. What is FHIR Sync Agent and why do we need it? FHIR Sync Agent is a data synchronization solution between two data service platforms, Azure API for FHIR and Microsoft Cloud for Healthcare. Please note that Azure API for FHIR is a part of Azure Healthcare APIs. And for the context of this FHIR Sync Agent talk, we would be referring it as Azure API for FHIR or FHIR service. And Microsoft Cloud for Healthcare backend is Dataverse. Why do we need Sync Agent? So Azure API for FHIR and Dataverse are two different services where Azure API for FHIR uses a flexible data structure in JSON format, while Dataverse uses a relational data tables and columns. So FHIR Sync Agent is created to synchronize data between these two services. Before we go further, we wanted to emphasize on the following the premises and guidelines. Only a subset of FHIR data is synchronized between Azure API for FHIR and Dataverse. Only a patient resource is sent to and populated in Dataverse. All patient clinical and financial data, such as encounters, observations, and appointments are sent to Dataverse only after patient consent. All subsequent data changes for consented patients are synchronized automatically. This reduces the amount of FHIR data that is synchronized with Dataverse. The FHIR Sync Agent assumes that all patient data originates from Azure API for FHIR. The Sync Agent does not prevent you from creating patients in Dataverse. Data synchronization is triggered by an event or a message. Data exchange occurs quickly, not in real time. Only metadata is stored in the service bus queue. No FHIR or patient health information is stored in any service bus queues. You can turn off or turn on which elements to sync. By default, patient or contact records in Dataverse are enabled for synchronization. For all other data, do not sync the data if you do not need it in FHIR. The important thing to understand here is the FHIR Sync Agent does not interact with any electronic medical record systems directly. The FHIR Sync Agent does not read data from an EMR system, nor it writes back to an EMR system. Instead, Azure API for FHIR is responsible for data ingestion from an EMR system and data write back to an EMR system. Where does this FHIR Sync Agent fit in? If you look at the typical architecture, FHIR Sync Agent is a service that sits between Azure API for FHIR and Dataverse. With the data synchronization solution between Azure API for FHIR and Microsoft Dataverse, enables you to access Azure API for FHIR data directly in Microsoft Cloud for Healthcare solution, which is powered by Microsoft Dynamics 365. Once the data is in Dataverse, you could leverage the power of Microsoft Power Platform. Applications built on Dynamics platform makes use of Dataverse and can operate without needing to make REST API calls directly to Azure API for FHIR. So on this Tech Talk, we'll explore further on these highlighted areas. Since the FHIR Sync Agent helps to sync between two solutions, we concentrate around the FHIR Sync Agent. This is an expanded view of FHIR Sync Agent highlighted in previous slide. At a high level, we have Azure API for FHIR, and at the bottom of it, we have a FHIR Sync Agent on Azure, FHIR Sync Agent admin app, which is responsible for entity and attribute mapping, plugin service from the platform, and finally, FHIR proxy in Azure. FHIR proxy serves as a middle tier application access and authorization endpoint. In the next few slides, we go through each of these components, right? Uh, Let's go through each of the FHIR Sync Agent components. The first component is the Sync Agent in Azure. It consists of the following resources. An Azure Key Vault, essentially to safeguard connection secrets used by Azure functions. Also have an Azure Service Bus with two queues. One queue to hold the messages coming from Dataverse, and the other queue called FHIR Updates. This holds the messages coming from the FHIR service going to Dataverse. Both queues maintains order of the messages coming in and also holds the temporary storage of messages while in flight. In addition to these service bus queues, we also have an Azure storage to bulk load the data and process into Azure API for FHIR. Uh, in addition to these Key Vault message queues and the storage, we have three microservices or three Azure functions. The first one is FHIR ND JSON file loader, which is essentially used to bulk load data from the Azure API for FHIR. The next one is the processing CDS updates function, which reads the messages from the CDS update queue and processes it to the FHIR. The third one is the processing FHIR updates. It loads the messages from it takes the messages from the FHIR update queue, which are coming from the Azure API for FHIR, and sends it to the Dataverse. In addition to that, we have application insights for central logging of the Azure function messages and event processing. On top of it, we have an app service and an app service plan to support all of these resources. Next, on the Dataverse side, we have a Dataverse plugin services, a platform plugin service that is available. And the second one is second component is FHIR Sync Agent admin app that comes with Microsoft Cloud for Healthcare installation. These both are sitting on the Dataverse side of things. Next, we have a FHIR proxy. It's a FHIR proxy is an Azure function and acts as an intelligent and secure gateway to Azure API for FHIRs. It also has support for pre and post processing. It is integrated with the Azure Active Directory for authentication to provide the RBAC, acts as a FHIR-specific reverse proxy in rewriting responses and brokering requests to FHIR servers as well. So if you look at the components, it's a Azure function with its own app service and app service plan along with the application insights. So far, we have covered the FHIR Sync Agent architecture and components. Now let's cover the typical data flow from the EMR system going to the Azure API for FHIR and then to Microsoft Cloud for Healthcare. So typically, we have an EMR system, and from the EMR system, the FHIR bundles would be synced to Azure API for FHIR through FHIR proxy. So whenever this FHIR resources is created in Azure API for FHIR, that notifies back to the proxy, and the proxy would send a message to the FHIR updates queue on the FHIR Sync Agent side. The Azure function called processing FHIR updates would process that message to the Dataverse or to the Cloud for Healthcare side of things. And once those, if there are any updates made on the Microsoft Cloud for Healthcare, those messages would be sent via the plugin service available on the platform and sends to the CDS updates. queue, which is in the FHIR Sync agent. And the second function, the processing CDS updates, would process those CDS messages back to the Azure API for FHIR through FHIR proxy. And again, once that those messages are updated in Azure API for FHIR, notifies the proxy, and inside the FHIR proxy, you will have an ability to create the pre and post configuration steps. So let's say if you need need to update your EMR or EHR system, you can leverage these post configuration steps, and through the custom implementation of the write back, you can write back to the EMR system. In addition to that, for a one-time load of data, you can also rely on export function available in Azure API for FHIR, which exports the data into all the FHIR resources into a bundle, and you can load it into the Azure storage, and this FHIR ND JSON file loader will sync it to the Dataverse. So this completes the first part of this FHIR Sync Agent Tech Talk. We have covered what FHIR Sync Agent is and went into the details about the architecture and discussed the each components along with the data flow. And this is the second part of the FHIR Sync Agent Tech Talk. In this part, we'll cover about how to set up and configure the FHIR Sync Agent. This is the reference architecture for Microsoft Cloud for Healthcare. If you look at it, we have Microsoft Cloud for Healthcare on the top portion of this. And at the bottom, we have EMR, EHRs, and ingesting into Azure API for FHIR. If you pay closer attention to this one, right, this FHIR Serious Sync Agent is communicating through FHIR proxy or FHIR gateway to Azure API for FHIR. It is not directly communicating with Azure API for FHIR. So this is the important piece that we need to understand before we get into the installation and configuration of the FHIR Sync Agent. Now let's talk about the FHIR Sync Agent setup and configuration. So we'll start with the prerequisites needed before you install the Sync Agent. In terms of the prerequisite, first we need Microsoft Cloud for Healthcare environment. We also need Azure API for FHIR, and then FHIR proxy needs to be installed before going to the Sync Agent installation. So any of the Microsoft docs on Azure API for FHIR deployment would help you in installing the Azure API for FHIR. Also note that Azure Healthcare API is the evolved version of Azure API for FHIR and offers additional technology and services. Existing customers can continue using Azure API for FHIR without disruption in service or change in pricing structure. We cover about the FHIR proxy setup in the next slides. In terms of the order of installation, you need to set up the Microsoft Cloud for Healthcare environment, then install the Azure API for FHIR, followed by the FHIR proxy installation in the same resource group as that of the Azure API for FHIR. Then install the FHIR Sync Agent in the same resource group as that of the Azure API for FHIR and FHIR proxy. FHIR proxy is one of the prerequisites that you need to install before installing the FHIR Sync Agent. So we cover this setup here. First, you will need Azure Global Admin Access to install the FHIR proxy. So in terms of the setup steps, the following information is needed to configure this FHIR proxy. So the client ID of the FHIR service clients, it's nothing but the Azure AD application that you create for Azure API for FHIR. And then the client secret from the same application, the Azure AD tenant ID for the Azure API for FHIR. The audience and resource for the Azure API for FHIR, typically your something.azurehealthcareapis.com, right? So these are the things that you need before you go ahead and run these scripts. So Yeah, for the in terms of the installation, right? You log into the Azure Cloud Shell from the Azure portal and clone the FHIR proxy repository that is available publicly, and then navigate to the scripts folder and run deploy FHIR proxy.bash scripts and follow the prompts. Now, we'll have a secure Firefox instance with authentication running. You can add users and groups for the authorized users. At a minimum, right, users must be placed in one or more FHIR server roles in order to access FHIR server or Azure API for FHIR via the proxy. The access roles are administrator or resource reader and resource writer. Here are the some of the here is the link to the FHIR proxy repo, which is on the GitHub. The next step is to install the FHIR Sync Agent. So in order to install the FHIR Sync Agent, you can request the installation, the latest installation files for FHIR Sync Agent from your fast track solution architect. At this point, these FHIR Sync Agent installation files are not available publicly. So you have to make that request to your fast track solution architect. In terms of the preliminary checks, uh, you need the Azure Global Admin Access and Dynamics 365 Admin Access to set up the sync agent. In terms of the prerequisite, you need to create two service client Azure AD apps, one for Fire Proxy and one for Fire Sync administration app. And also, like we discussed in the previous slides, ensure all the other prerequisites are in prerequisite applications are installed. That is Azure API for Fire and Fire Proxy. In addition, if you need to create a Postman environment, you can run this script that will connect, that will create a Postman environment and connects to the Azure API for Fire. Let's go into the details of the FHIR Sync Agent installation. Once you receive the latest installation files, upload into your Azure environment, and log into CLI and navigate to the scripts folder. Once you navigate to that folder, run that deployment sync agent.bash script. This script would need the key vault name that is installed with FHIR proxy, the resource group location, resource group name, and sync agent prefix. After successful execution of this script, the following components will be installed. That is sync agent with the app insights and storage. It also creates an app service plan for this function app, service bus namespace and queues, service bus namespace policies and authorization rules. And note that the FHIR bulk load queue is disabled by default. It should only be used in specific cases. Please refer to the following URL to understand the configuration values loaded by this script. Once you deploy the sync agent, the next step is to run this setup sync agent.bash script. And this script needs the following resource group and the FHIR proxy app names, along with the Azure Key Vault that is installed along with the FHIR proxy, Dataverse instance URL, Dataverse tenant ID, Dataverse client ID, and client secret. This is from the Azure AD app registrations that we have done in the previous step. Step 3 is to enable or disable sync agent communication. You can run this control sync agent .bash. This script applies the FHIR proxy post process modules to enable sync agent communication. After installing the FHIR Sync Agent, the next step is to do the configuration on the Dataverse side. So in order for this to happen, obviously we needed Cloud for Healthcare environment, Azure API for FHIR, FHIR proxy, and FHIR Sync Agent installed and configured. In terms of the configurations, we need application user creation, assign roles to the application user, and integration settings. We'll cover all these in the next few slides, along with on how to enable and disable the synchronization of Dataverse entities. We'll also explore and enable the standard entity maps that are available out of the box. We'll add some additional information on how to create new entity maps towards the end of this part. The first step of the Dataverse configuration is to create an application user. So to create an application user, right, there's a FHIR Sync Agent administration app that comes with the Microsoft Cloud for Healthcare installation. So open that FHIR Sync Agent administration app and navigate to the application user from settings, security, and users, and change the form to the application user form. And on the new user screen, make sure the view is application user and then populate the values as per the detail below. You need the username. Provide a name for your FHIR Sync Agent app user. In addition, the application ID is the application ID created for Azure AD FHIR Sync Agent. And then application ID URI, this will be auto-populated on saving the record. Same with the Azure AD object ID. For the full name and primary email, provide the first name and as FHIR Sync Agent and last name as app user, and provide a dummy email address. This creates the application user on the Dataverse side. After creating the application user in Dataverse, you need to assign roles. You can assign the roles from the manage roles on that user and select the FHIR Sync Agent app res user. This role gives the sync agent the access it needs on the Dataverse side to access attribute and entity maps. In addition to this FHIR Sync Agent app res user, there are two additional roles. One is FHIR Sync Agent config administrator. Helps administrators to create and manage the sync agent maps. The other one is the sync agent healthcare user. This needs to be assigned to all users of Microsoft Cloud for Healthcare when the sync agent is being used. After assigning the FHIR Sync Agent app res user role to the application user in the Dataverse, the next step is to configure additional integration settings. These settings are essential to post the messages back into the FHIR Sync Agent service bus queues. This also helps to prevent a continuous loops of updates to FHIR. Please note that if you enable integration of switch here, these cannot be editable, and make sure the enable integration switch is on in order to update these settings. We'll discuss about these environment variables in the next slide in detail. To configure these integration settings, we need the following, right? For the Sync Agent client ID is the client ID of the Sync Agent Azure AD app registered for FHIR Sync Agent. Service bus URL is the service bus endpoint. For service queue is the name of the service bus queue. Service bus shared access policy is the key name. Service bus shared access policy key is the shared key to access the related service bus queue. You can gather these four values from the Azure service bus on the FHIR Sync Agent. Now, after configuring the Dataverse integration settings, let's take a look at the mappings available within FHIR Sync Agent administration app. To reduce the need to manually create entity maps for FHIR resources, FHIR Sync Agent includes built-in entity maps, attribute maps, and FHIR element maps that support all standard FHIR resources you are likely to need. FHIR Sync Agent administration includes 22 entity maps and 360 attribute maps out of the box. Additional information on the included maps can be found at the link here. Let's say if you do not need an entity map that is included with FHIR Sync Agent, you can disable the entity map. For example, you might not need to have a medication request record synchronized and stored in the EMR system. So to disable that, open the FHIR Sync Agent administration app, go to the entity map and select that entity map for that medication request record and click on disabled, set the disabled flag to yes and save the record. And that would disable that particular map that you no longer need to sync with the EMR system. You can also disable the attribute maps for the attributes that you do not want to sync with the FHIR Sync agent. In addition to disabling the maps, out of the box maps, you can also add or create new entity maps and also create new attribute maps. The mappings, there are 5 types of mapping types that for FHIR and Dataverse mapping. The first one is copy data. It is essentially used to copy the value as is from FHIR to Dataverse and vice versa. Mapped value, let's say in FHIR, we use male and female for gender in patient, and the corresponding Dataverse field use different values. Let's say it's integer 1 for male and 2 for female. In those cases, this mapped value is the right mapping type. And the third type is the set default value. This helps to set the contact type attribute. Same entity, for example, in Dataverse, contact is used to store patient and practitioner. A contact type is attribute is used to differentiate between these two FHIR resources. So in those cases, this set default value is used. Foreign key reference is used to set the foreign key reference. So in cases in both FHIR and Dataverse refers to another resource type or entities used using the data ID or primary key. In those cases, the foreign key is the mapping type that you need to choose. Lookup codable concept. Similar to foreign key reference, this is similar to foreign key reference, but the difference is these values are not primary keys. For example, in Dataverse, device type uses predefined values that exist in a different entity called codable concept. In FHIR, this is defined as a codable concept and their value vary by resource type. So these are the 5 available mapping types that you can leverage when you are creating a new entity, a new attribute map. So we have included additional information from our docs link to create a new entity map or create a new service attribute map, and also added some additional information on how to get to the sync agent log, as well as some additional information on FHIR Sync Agent administration. And this completes the part 2 of the FHIR Sync Agent Tech Talk. In this part, we cover about FHIR Sync Agent integration scenarios with sample use cases. The following scenarios can be handled with the FHIR Sync Agent configuration. EMR, EHR to Azure API for FHIR. Either you can use process FHIR bundle via Postman or process FHIR bundle from a file share. An additional setup may be needed here. That is, FHIR data loader needs to be configured. You can configure, or you can process HL7 messages. Again, additional setup is needed. For example, EMR or EHR would be on HL7 format, but the Azure API for FHIR is expecting an Azure in FHIR resource. So there is a FHIR converter available on our GitHub repository. So this needs to be configured before you process the HL7 messages. In terms of sending updates from Azure API for FHIR to EMR or EHR, you can choose to implement your custom implementation of this write back. Some of the options include export from Azure API for FHIR and leverage this functionality to integrate or write back to your EMR. Azure API for FHIR to Dataverse, bidirectional. Dataverse to analytics. For analytics, we can use that is Power BI, Data Lake, Databricks, etc. And then Azure API for FHIR to analytics. Let's go through some sample use cases for the FHIR Sync Agent integrations. So if you have either HL7 or FHIR resources coming from the EMR or EHR systems, you can do a conversion to a FHIR using FHIR converter, and that messages would go to the Azure API for FHIR through proxy, and whenever that gets into the Azure Healthcare APIs, that posts back to the FHIR updates queue, which would eventually sync in to the Dataverse through the sync agent. Similarly, from the Cloud for Healthcare application side, if any of the data that gets modified either through care management or home health or any of the Cloud for Healthcare solutions, that update gets posted to the CDS update queue, which eventually goes to the Azure Healthcare API uh, through the FHIR Sync Agent. In cases where you need to load the bulk data, you can use the FHIR bulk loader that is available. You can configure the storage bulk loader with the Azure storage and can populate that storage, which essentially follows the same pattern and takes the data to Azure API for FHIR through FHIR proxy and the corresponding FHIR Sync agent syncs that data between Azure Healthcare APIs to the Dataverse. To provide some additional details about the integration scenarios that we discussed in the previous slide, this gives an additional details. For example, on the left side, we have FHIR based EMR or EHR or for our HL7 versus CCDA resources. In that case, you can use the FHIR converter. Basically, what it does is it takes the HL7 and CCDA formatted messages, and this converter converts into a FHIR formatted message and posts to the FHIR proxy, which eventually gets into the Azure API for FHIR. And based on the configuration and the setup we discussed during this tech talk, it posts to the Dynamics 365, and any updates from there comes back to the FHIR proxy and processes to Azure API for FHIR. And in cases where it needs to be written back to the EMR, a custom implementation need to be put in place. If you put the integration scenarios into our architecture and component, this is how the flow looks like. From the EMR or EHR systems, there is a FHIR data ingestion that goes into the FHIR proxy or gateway, which sends the data to Azure API for FHIR. And once it's sends the data, it also puts a notification to through a FHIR proxy and sends it to the respective service bus queues, and that Azure Sync Agent would process those messages to the Dataverse. And again, the message is coming from the Dataverse gets processed to through Azure FHIR proxy to Azure API for FHIR, and if there are any write backs, it'll write. This needs to be a custom implementation, writes to the EMR back. In cases where the bulk data needs to be loaded, you can use a export function out of the Azure API for FHIR and rely on the FHIR bulk loader to load the data into Dataverse. Let's discuss some of the best practices and performance considerations that you can do while setting up the FHIR Sync agent. Consider the following best practices for the initial data loads. When loading data from EMR or EHR to an Azure API for FHIR, prepare the data in the FHIR bundle format. For HL7 messages, you can use the FHIR converter that is available. Also, try to include the MPN or EPID in the FHIR bundle. Essentially, this is the unique patient ID from EHR or EMR. Load all the FHIR bundles in a file share. Uh, Process FHIR bundles from a file share using FHIR loader. And this FHIR loader will resolve all internal in the bundle and append all resources to an ND-JSON file with one resource per line. So this helps in terms of processing large volumes of data. Uh, in terms of loading data from Azure API for FHIR to Dataverse, the important thing to understand is FHIR Sync Agent assumes EMR is master and Dataverse is empty. Export data from Azure API for FHIR using export command, that is bulk export feature. Export at the patient level instead of the system level. uh, this export function loads an Azure storage with the patient data, each row consisting of one patient related resource. In case you have populated the FHIR resources with MPN or EPID, that is the unique patient ID from EMR to EHR, make sure there is an attribute mapping in Dataverse using FHIR Sync administration app prior to starting the data load. Manually trigger the FHIR ND JSON loader function, which loads the data into Dataverse through FHIR proxy. There are additional best practices that you can consider to enhance the performance of the FHIR loader. FHIR loader supports like three different formats: FHIR bundles, right, and ND-JSON files. Basically, a new line delimited JSON is a format for storing structured data, and that is used while processing records, one record at a time. In addition, this FHIR loader also supports compressed FHIR bundles in zip format, which allows to move a large amount of files efficiently through Azure networks. So of all the three formats, zip provides the fastest load times. In terms of the environment, the loader really relies heavily on the network-based storage. Therefore, we recommend you deploy the loader in the same region as your Azure API for FHIR. Right. Same applies to the resource group. The loader can be stored in the resource group other than API for FHIR, but it's extremely important to apply all security measures to protect PHI in the cloud. For the storage container, I set to standard hard access tier, depending on how files are being moved into Azure. That is either Azure Data Factory or versus Azure Copy. You will want to consider the separate storage account for input storage. Then simply move the files from incoming storage to the loader containers. You can also refer to the performance tuning documentation provided here. For Azure resources, consider these best practices in terms of performance improvements. So for app service plan, the compute resources are determined by the plan that you are on. So for loading, we recommend using an app service plan that supports production scale. You can always scale back after loading the data to reduce the cost. You can refer to the link on this app service plan here. In terms of the function app, the loader function comes with max connection setting of 20 processes for connecting to backend system. Be cautious while adjusting this as queues into service bus or event grid can increase delay to maintain consistency and order. Again, you can follow the scalability best practices available through our docs link, and the link is also shared here. In terms of a service bus, we recommend having a premium tier service bus to address common customer requests around scale, performance, and availability. Follow the service bus scalability best practices, and the additional information is available in this link as well. In terms of the application insights, FHIR Loader is deployed with application insights and is recommended that customer and partners use application insights to monitor load performance and potential issues. With respect to the API for FHIR, right, refer to the following on archive achieving higher throughputs with Azure API for FHIR. This gives additional best practices on how to achieve maximum throughput. And this completes our tech talk on FHIR Sync Agent. Thank you.